Okay, so this video I'm just showing some software I've been working on, which is a concatenative synthesizer. And what that does is take lots of little snippets of audio and sort of mosaic or collage it together to create a longer output bit of audio. And the way I'm doing that is I'm downloading videos from YouTube that are based on these words that are getting passed in. This is a list of words, all very generic words. All they're actually generated by ChatGPT. These words, and what the code does is create little phrases like two words long or 3 words long by combining these words, and then searching YouTube for those keywords and then downloading a video and extracting little slices of the audio from that. So I probably easiest to just show it here. It's a command line program at the moment, so I run it by doing something like this. So it's called concat-synth. I'm telling it to download from YouTube using these words as the input, a fade between the snippets that it makes of 30 seconds, and an output length of 20 seconds. So what I'll do is actually download a lot more audio and make the output something like 30 seconds. So what this will start doing is now downloading from YouTube 128 little clips. So you can see it starting. It's downloading Vortex Horizon, Mirage Quartz, Mirage Harmony. So what it is actually doing, like I said, is going onto YouTube and it's downloading these bits of audio. And you can start seeing it coming in here now in this audio download file. So if I click on this, okay, Visual Studio Code seems to have lost the ability to play audio for some reason. What I can do is play it here, I guess. So if I do AF play, audio downloads, Aurora, Eclipse, and just listen to that. There we go. It's a very short clip that has come from YouTube. We can try playing another one. Frost Mistral. I don't know how to say that. So there we go. So it's just downloading little snippets, and we can choose how long we want the snippets to be. Unfortunately, it takes absolutely ages to download all of these videos, so in the meantime I'll just show a bit more of where I got this idea from. And I was reading this paper from a guy called Diemo Schwartz at IRCAM, and he's talking about like the origins of this kind of thing and what you might want to do with it, and how you know, this is basically roughly what I'm doing as well in the code. It's following this image here where you get these source sounds that you download from YouTube. That's a bit I've mentioned already. You analyze the sounds, so you extract features of the sound, like features about the spectrum of the sound, the energy of the sound, the loudness, and the pitch, that kind of thing, and you put them into a database. So you get this, what is called a corpus of the sound, into a database, all analyzed with different features. And then you basically, what I'm doing is trying to then make a path through that sound, and for each sound that it starts with a random sound from the database, and then it will pick another one based on similarity to the previous one, and that's where it uses those analysis results. So if a sound has a similar pitch to the one before it, it's likely that it will try to pick that one. And there are these equations in this paper for how you can determine that. So what it does is basically it tries to find, for each sound, it tries to find the nearest neighbor to that. So you have this space of sounds, which I'll show you in a minute, that you can plot, and then you basically find in 2 or 3D space, depending on how many features you have, for example, which two sounds are the most similar in terms of pitch, loudness, energy, that kind of thing. So it attempts to like make a sort of intelligent path through the audio. but it's completely unguided what I'm doing. What actually they normally do, what he does here, and what I haven't got, is this target. So with the target, you could have like a phrase or an existing piece of music, and what it does then is it tries to pick from this database of sounds at each moment, at each slice, say, which so say you were looking at 0.1 seconds at a time. At each 0.1 second, it will look in this database to what is closest to that particular part of the audio in the target, and it will try to reconstruct that target using the sounds you provide it, which can give you quite interesting results. What I'm doing is not using this target, and I'm just sort of like allowing it to create a random path through the audio. And if I look here now, back here, we can see that it's all finished. All the videos got downloaded, and it did the analysis of them all, and it gave me this 30-second output clip. And the most important question is, does what comes out of this sound good? And the answer to that question is unfortunately no. So I'll just play it, what we got.
Take back. Worse. Hit a bit. Next beat. Hit a bit. Next beat. Hit a bit. Next beat. Hit a bit. Next beat.
There we go. So you get the picture, right? It's just mosaic these sort of random clips together, and I can show you like what is actually going on a bit more there. If I run this script I've got, it will actually again, it'll take a bit of time because it has to read all of the analysis here, but you can see that like for each audio sound we've got this file name, and it calculates these features: root mean square, which is kind of like basically where the loudness of the sound, the pitch of it, which when it says nan, it means that it's like an unpitched sound. So like if you have like noise or something, there's not going to be any pitch information in it. And spectral centroid, that's kind of like the energy in the frequency domain. So with those three features for every sound, if we go through all of them, we can then, all 128 sounds, we can make this map of the features. So what this is plotting is the root mean square against the spectral centroid, and the color of the circles is the pitch. So what you see here is the map of all the sounds. So all 128 sounds are here, and from that you can hover over one and see for a particular sound what its root mean square was, what its pitch, and what its spectral centroid is. And this red sort of path going through it is exactly that. This is the path that the code has decided to join up these bits of audio. So it starts here and it ends there. So it goes from here over to there. And what it is doing is finding the closest sound across these three dimensions. So the sound that, for this sound, the nearest sound to it is this one, in terms of the spectral centroid, the RMS, and the pitch. So if you listen to the start sound, and then you listen to the next one, these are the closest sounds to each other that it's finding a route through. What I will show you now, because this isn't what we actually heard in the clip I played you earlier, it was generated by a different process. There is a way where, what you might have noticed in the clip I played originally, this one.
Hit a bit. Next beat. Hit a bit. Next beat.
Is that
hit a bit.
It kind of starts just looping. You get into this loop basically, and the reason for that is it starts just fine. It just stays in a little cluster where they're all quite similar. Like if you look at the plot again, I closed it, so it's going to generate a new plot again now. In the plot, what you see is that that one corner had quite a lot of sounds in it. It wasn't much representation in the top right, but in the bottom left, where all these similar sounds are, they're all quite similar to each other. So eventually, it just gets into a loop where it starts picking the same sounds again, and it's not very evident here. I mean, it goes through quite a few different sounds here. I think there's 60 unique sounds in this plot here. But if I reduce the history, if I change this to 1, so what it's doing, it's like saying, don't revisit a sound again unless if it's been found in the last 10 sounds. But if I change that to 1, so that it just basically just doesn't keep track of anything, of what sounds it's seen, and I run it again, what happened now is that you'll see it basically just oscillates between 2 different sounds because it's looking for the nearest neighbour to a sound, and it'll say, okay, sound A is nearest to sound B, and then sound B will say, well, I'm nearest to sound A, so go back there, and then sound A will say, I'm nearest to sound B, and it'll just keep going back and forth like that, basically. So if I run that now, you should see that in the plot, that it just like gets stuck in this alternating path. So where last time I had 60 unique sounds, we should probably have quite a lot less now. I was just doing the analysis again, so bear with it for a while. So now we only have 3 unique snippets in the path. There we go. It just there's no path at all now. It's just going back and forth between the two, which is not good. So if I make it, a bit bigger, like 5, say, and run it again, you'll have a slightly better path. But again, you'll see hopefully in the picture that it will that it's obvious that it's just going between the few in a loop, basically. And that's why you hear this repetition in the sound that comes out. So just wait for it to process again. Yeah, it's not that clear actually. How much did we get here? So we still got 40, but I think somewhere around here it just starts like looping around basically. So you get this kind of like square thing here that it gets stuck in for a while. So yeah, that's just an overview of this program that I've been working on.